Let us look at proposition number 11 of book 13 of Euclid's Elements. The proposition says, if an equilateral pentagon is inscribed in a circle which has its diameter rational, then the side of the pentagon is the irrational straight line called minor. So here we have to show that AB is a minor. Let's see how we can do that. Given a circle ABCD with a rational diameter and an inscribed pentagon ABCD, take the center F, draw AF and BF, carry AF to G and BF to H, join AC, and M is the intersection of AC and BH. So join AC and the intersection of AC with BH, let's mark it as M. Now let's also mark the intersection of AG with CD as L. Now make FK equal to 1/4 of AF. So 1/4 of AF and mark it on BH. So here FK is equal to 1/4 of AF. So now FK is rational. Since AF is rational, BF is rational because AF and BF both are the radii of the same circle. So since AF is rational, BF is also rational. So BK is also rational. Circumference ACG, which is half of the circle, semicircle, is equal to the circumference ADG, which is the other semicircle. So naturally, these two will be equal. Now, in them, circumference ABC is equal to AED. So, which means the remainders, circumference ACG minus circumference ABC, that is circumference CG, is equal to GD. Join AD. So here angle ALD and angle ALC will be right angles, which means CD is equal to 2 times CL. Similarly, we can show that AMH is equal to CMH. Both are right angles, which means AC is equal to 2 times CM. So, since all these 4 angles are right angles, we can say angle ALC is equal to AMF, which is the same angle as AMH. And angle LAC is common. So where is, for what is angle LAC common? For these two triangles, angle LAC and FAM. In these two triangles, LAC is common. So that means two angles are equal to two angles in these two triangles. That means the third angle will also be equal, which means angle ACL is equal to MFA. So which means triangle ACL is equiangular with triangle AMF. And since they are equiangular, that means sides about the equal angles are proportional. That is, LC is to CA as MF is to FA. Let's double the antecedents, that is LC and MF. So 2 times LC is to CA is equal to 2 times MF is to FA. But 2 times MF is to FA can be written as MF is to half of FA. So 2 times LC is to CA is equal to MF is to half of FA. Now we are going to half the consequence. So consequence are CA and FA. So 2 times LC is to half of CA is equal to MF is to 1/4 of FA. So 2 times LC is what? Is CD, and half of CA is CM is equal to MF is to 1/4 of FA is FK. So we have CD is to CM as MF is to FK. Taken jointly, this becomes CD plus CM is to CM is equal to MF plus FK is what? MK is to FK. Let's take the squares on all of them. So CD plus CM square is to CM square is equal to MK square is to FK square. We have seen previously that if we have this proportionality, then CD plus CM square is equal to 5 times CM square, which means MK square is equal to 5 times FK square as well. Since FK square is rational, we have seen this. FK is rational, which means FK square is rational, implies MK square is rational, and so is MK. Now, since BF is equal to 4 times FK, because FK is 1/4 of AF. AF is equal to BF. So we can say AF is equal to 4 times FK, which means BF is also equal to 4 times FK. So which means BK is 5 times KF. We again take the square. BK square is equal to 25 times FK square. Now, since MK square is equal to 5 times FK square, implies BK square is equal to 5 times MK square. So here, if you notice, the ratio between BK square and MK square is 1:5. And 1:5 is not a number, is number square is to number square ratio. So which means BK is incommensurable with KM. So BK and KM are rational straight lines incommensurable in length. BK minus KM is equal to BM. So BM is an upper-tone where MK is the NX. So we have reached this stage. If you're not familiar with book 10 propositions, you're going to find this a little bit incomprehensible. Let's take n square equal to the difference between these two squares. That is BK square minus KM square. So let us say this is n. So n square is equal to BK square minus KM square, which implies that BK square is greater than KM square by n square. BK square is 5 times KM square, which means BK square is to KM square is equal to 1:5. So in conversion, BK square is to n square is equal to 4:5. So therefore, BK square is to n square is not equal to number square is to number square. So BK is incommensurable with n. So BK square is greater than KM square by the square on a straight line incommensurable with BK. And BK is commensurable with BH, a rational straight line set out. Because remember, BH is the diameter. And we started off by saying that ABCD is a circle with a rational diameter. So BH is rational, BK is rational, so which means they are commensurable. So based on all this, we can say BM is a fourth epitome. When AH is joined, so let's join them. Triangle ABH is equiangular with ABM. Because they are equiangular, we can write it in proportionality form. We can say BH is to AB as AB is to BM. And this can be written as BH by BM is equal to AB square. So here AB square is an irrational and AB is minor. How did we arrive at this? Because we are having BM as a fourth epitome. BH is a rational straight line. So a fourth epitome applied to a rational straight line gives us an irrational straight line whose square root is minor. So we have shown that given a circle ABCDE inscribed by a pentagon which has its diameter rational, then the side of the pentagon is a minor. So that is proposition number 11 of book 13 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.